Hello students, this video is about graphing trigonometric functions, and this time we're going to add all of the bells and the whistles. So, first of all, there's some things that you already know. You already know that the amplitude is A, that the period is 2 pi over B. Well, this value C shifts the graph. It's actually a phase shift, and the phase shift for the graph is negative C over B. And this value D is the midline of the graph. It's going to move it vertically. All right, so there's what you need to know. So these things, the amplitude, the period, phase shift, and midline, they are the same for both cosine waves and for sine waves. And actually for tangent, the only thing that's different, the period is different from tangent. Okay, so first thing I'd like to do is just talk about what this C and D mean, what they're actually doing, right? So this C in here is a horizontal shift. So it's just like you learned with parabolas. You remember with parabolas how you had that C value that was moving it horizontally. It moves it the opposite direction. And we know it's going to move it horizontally because this addition is inside the parentheses. When it happens inside the parentheses like this, it's affecting the x values. That means it's going to move horizontally. Whereas when it's happening on the outside, and we have this plus here without the parentheses, or what's outside, that is moving it vertically up and down. That's going to move the whole graph up and down. So we have our D here. This D value is moving the graph vertically. So the midline, if it used to be here, it's going to shift the graph up, right? So if D is positive, then this is going to move this up. So this is like a positive D. But if D were negative, what would happen? A negative D would shift the whole graph down. So like again, on the outside, that is the vertical shift. Now let's look at the phase shift. How does the phase shift move the graph? Okay, so a phase shift moves the graph horizontally. The things inside here move it horizontally. Okay, so now these values are tricky because they move it the opposite direction than what you would expect. You would think that if C were positive, it would move it positive and negative, negative, but it's actually opposite. When we have a positive C, it moves it negative. So since I moved this positive, I must have a negative C. This negative C here means that my shift is going to be positive, whereas a positive value of C would move the graph negative to the left. So this is just like when we were learning with quadratics. The C value, adding to the x's move opposite than what you would expect. So now the next question is, how do I graph these? Because it looks like the shape that I've drawn here, this is the sine shape. So we've already learned how to draw the shape of a sine wave, how this looks. First you have to find your midline, okay? And the midline could be on the x-axis or it could be moved up or down. You have to find that wherever that is. And then you're going to do your shift, so you have to find out where you start. And you start right on that midline. Then you have to add your period to that point to find out where you end. Okay? So you count the squares to your period to find where you end. Then you find a point in the middle. And halfway between these, you have to count up your period. And halfway between the second two, you count down your period. And there is your basic shape for sine waves. Now cosine's a bit different. You're going to find your midline, but instead of starting down on the line, you find the starting spot, then you have to count up your amplitude, and you start at the top of your amplitude. Then you add your period to find where you end, but instead of being down the line, you have to end up at your amplitude. Then you find the spot in the middle, and at the middle, you count down your amplitude. Halfway in between here is where it crosses, and halfway in between here is where it crosses. So we draw cosine waves like this. All right, and then for tangent, how do we draw tangent graphs? Well, for tangent, we have to find this starting spot. Then we draw in the asymptotes. Okay? And then after you draw in the asymptotes, halfway in between here, you come up to your amplitude, and halfway in between here, you come down to your amplitude, and then we can draw in our, this is our A value right here. Then we can draw in our tangent graph. So that's how you can draw the basic shape for sine, cosine, and tangent. But let's look at some examples of drawing these that have shifts in them. Okay, let's see if we can graph this example. The first thing we're going to do is find all of the relevant information. So first of all, let's get our amplitude. Our amplitude is 4. Okay, it looks to me, I can see that the pieces are out of order. This is my A and B and C, and instead of putting D on the end, it looks like D is actually in front. This is the value for D out here. All right, so that's okay. You're allowed to do that. That's fine. Okay, so A is 4, and the period. The period is 2 pi over B. And what's my B value? Looks like B is 2. So 2 pi over 2 means my period is pi. Now let's find the phase shift. All right, so the phase shift is C over B. So C is pi over 2 over B, which is 2. Okay, so I have to simplify my fraction by doing keep, change, flip. Multiply by the reciprocal of the denominator. That means that my phase shift is pi over. All right, and now let's find the midline. The midline is at -2 because that's the D value. All right, so now we are ready to graph it. Yep, that's everything. Let's graph it. So start by putting in our midline. Our midline is at -2. Okay, now on this line we need to shift. We need to shift over pi over 4. Now because it's a negative shift here, I know that I'm going to move in a positive direction. So I'm going to come this way. Pi over 4. So pi over 4 here. So here's where we're starting. That's going to be our starting spot. All right, and if I add my period is pi. So my period being pi, I need to add pi to this to find out where I end. So let's see, I'm starting here. I can see that every square is 1/4 of a pi. So 4 squares makes a full pi, so I'm going to add 4 squares. 1, 2, 3, 4. This is where I'm ending. Okay, now I'm ready to draw my cosine wave. So I'm going to start at the beginning, and I'm going to come up to my amplitude of 4. So come up 4, there's my starting spot. And then at the end, I'm also coming up 4. 1, 2, 3, 4. In the middle, find the middle between those two. The middle would be right here. So in the middle, I'm coming down 4. 1, 2, 4. And then halfway in between these two is where it crosses. And halfway in between these is where it crosses. And I have my cosine wave. So now we can continue that pattern to go fully across the paper. And yes, you should draw it fully across the paper because it's beautiful if you draw it out. So let's just continue the pattern, counting the same number of squares. Let's see, 1, 2, 3, 4, 1, 2, 3. All right, there it is. There is my wave. Now, when you're drawing this out, the other points that you add don't have to be as spot-on accurate. The ones that have to be correct, that I'll be checking are right, are the 5 points that we had here. If these original 5 ones are good, then the rest of that you can just continue the pattern on either side. All right? Let's try another example. Okay, example 2. Let's see. Our amplitude appears to be 2, and the period is 2 pi over b. What is b? It looks like b is 4. Okay, so that reduces to half pi. And then let's do our phase shift. The phase shift is C over B. So this over this. We've got pi over 4 over 4. All right, so we're going to have to do keep, change, flip with that guy. Keep the top, change to multiplication, flip the bottom. So it looks like our phase shift is pi over 16. Positive or negative pi over 16? Ooh, it looks like we have a plus in here. So instead of shifting this way, I'm actually going to have to shift towards off of the screen. Ooh, so I wonder if I'm going to have enough access here. So, and then the midline is what? +1. Okay, so now I'm ready to start graphing. I know my midline is going to be at 1. But when I get ready to draw this shift of negative pi over 16, I don't want to go negative, okay? And actually, this particular one, it looks like pi over 16 might actually fit on the graph because I can see that I'm counting by fourths here. So a half of a fourth would be an eighth, and a half of an eighth would be a 16th. So I could go negative 1/16 and actually fit on here just fine, but I'm not going to because I want you to know what you should do. If you get a shift that's shifting off the paper and you don't have enough room to draw it. So what you should do is, instead of graphing the wave that goes off the paper, what we're going to do is we're going to add in, instead of graphing the wave that goes off the paper, we're going to add in add the period to our negative number to find out where that next wave begins. Because I know that this graph is repeating again and again and again and again. So if I add the period, I can find the next one, and that will be the one that I want to use. So I'm going to adjust this by taking my phase shift, negative pi over 16, and adding my period. So to adjust, add period. That's worth writing down. Okay, to adjust a negative shift, add the period. So I'm adding the period to this, and in order to add two fractions, what do I need? Common denominator. So let's go ahead and multiply by 8 and by 8. Negative pi plus 8 pi will give us 7 pi over 16. Okay, so instead of starting at negative 1/16, I'm going to start at positive 7/16. So now we need to find that on our graph. Okay, so I need to find 7/16. So let's just kind of reason through that. 7/16. If this were 8/16, that would be a half, right? 8/16 would be half of pi. So it looks like I'm looking for just a little bit less than half pi. So here's half pi. I'm going to come back just a tad bit, and let's call 7/16 right there. Okay, so there we go. Here's half of a half. Okay, so 7/16 here. Now, from that point, we're going to add our period. Our period is pi. So how many squares is pi? It looks like every 2 squares is pi. So I'm going to add 2 squares to this, and where do I end up? Here. Okay, so now I'm ready to draw my cosine wave. So let's start at the start. At the start, we're going to come up to our amplitude of 2. And at the end, we're going to come up to our amplitude of 2. In the middle, find the middle between these two. Just count the squares, right? Find the middle. At the middle, we're going to come down to. Halfway in between here is where it's going to cross. Halfway in between here is where it's going to cross. And there she blows. So, great. So those 5 points are fine. Let's go ahead and continue the pattern across the page. Let's see, every 2 squares. And yeah, I just eyeballed that. So, But the first 5 points in the middle right here look great. Okay, let's try one last example. Alrighty then, last example, let's see. Looks like the amplitude, it's 2 again. What is the period? The period is 2 pi over b. 2 pi over, wait a second. 2 pi over b. Look at your x-axis here. It looks like the x-axis no longer has radians on it. I see numbers that have degrees. So instead of doing 2 pi over b, let's do this in degrees. So 2 pi, how many degrees is 2 pi? 2 pi is a full circle, that's 360. And b, what is b? b is 3. So it looks like our period is going to be a third of a circle, or 120 degrees. Now let's find the phase shift. The phase shift is going to be c over b, so that's 210 over 3. 3 goes into 21 7 times. That's 70 degrees for our phase shift. And midline. The midline is at 2. Now, every time you're doing these problems in your homework, I want you to list out the amplitude, period, phase shift, and midline. Okay? All right, so let's go ahead and graph it. We're starting at 2. Our phase shift is over 70 degrees. So here's 60, 70. Okay, then we're going to come over our period of 120. 120 is how many squares? 1, 2, 3, 4. So adding 4 squares to that. 1, 2, 3, 4. So at the beginning, we're going to come up to our amplitude of 2. At the end, come up to our amplitude of 2. Find the middle, come down 2. And in the middle of that is where it crosses. Ta-da! And continue that across the page. I'm just going to eyeball the rest of this. Alrighty, folks. So there is your crash course on graphing trigonometric functions. This one was featuring cosine, whereas the previous video that you've already watched featured sine. There's another video, a separate video, that's on tangents. So as you practice this yourselves, you're going to be masters of graphing waves. Good job.